Review, I'm going to talk really loud. Right, this is our graph of 1 over x. It's undefined for 1 over 0, so we can't have that. So that gives us our vertical asymptote, and that's always where we have division by 0. Wherever you have division by 0, that's going to create a vertical asymptote. And then our horizontal asymptote was going to be at y equals 0, because as x gets very large, 1 over a large number equals a small number. And as that gets bigger, the other ratio gets smaller. So what I wanted to do is summarize how to do the horizontal asymptotes, because we won't always have 1 over x, there'll be variations. If we look at the next two things, vertical asymptotes is just what we talked about. Any value that makes the denominator equal to 0, if it does not make it, if it does not make the numerator equal to 0, it's vertical asymptote. There will be some cases where it makes both the numerator and denominator 0, and that will create a different situation. There will be a hole in the graph. Right? So you may have seen that before, where the graph will have a continuous piece, and there will just be an empty spot or a hole in the graph, where it's undefined, but it doesn't create an asymptote because it's 0 in both numerator and denominator. When we say right here there can be more than one, if we were to look at a case where we had 3x over x squared minus 1 as a function, there are two places, right? What are the two places where the denominator equals 0? No, we add the 1, so which is going to be 1, negative 1. So there would be two vertical asymptotes in an example like that. And if we had 3 factors on the bottom, there could be 3 vertical asymptotes. But anywhere where we have a value that gives us 0 on the bottom, 1 squared minus 1 is 0, so that's a vertical asymptote. Negative 1, because both numbers would give you division by 0.